Hi, I'm Jim W6LG, your ham radio Elmer here on YouTube. Welcome to my radio room in Rocklin, California. Okay, I know this looks weird, but trust me, it's got some value. This is my switches board, and on the switchboard I've got two switches. They are coax switches. They're relatively good at HF. There's very little loss through these things. So the way I've configured this is with this switch in this position, the SWR connected here will show 1.5 to 1. If I flip this switch to here, it's now connected to these two, and this produces a 2 to 1 SWR. These are precision dummy loads for antenna analyzers. Then if I flip this switch from what is basically open to this other resistor, now I get a 3.0 to 1 SWR. What's the point of all of this? Well, when you see what happens to the SWR reading at the transceiver based upon the kind of coax, you'll understand why this has some value. So again, I can simulate an antenna with a 3 to 1, 2 to 1, or 1.5 to 1 SWR. Let's look and see what happens when I use, I've got 100 feet of LMR 400 and 100 feet of the gray RG8X. And let's take a look and see what the SWR appears to be at the transceiver. Okay, again, using the AA Zoom 3000, I get 1.5, 2 to 1, or 3 to 1 reading on my switches box, and I'm going to pick 3 to 1. And I'm going to hook up 100 feet of RG8X. So at the beginning of the RG8X coax at the antenna side, the SWR is 3 to 1. But now at the transceiver, instead of it measuring 3 to 1, it measures about 1.8 to 1. Now that varied just a bit with the length of the coax I was testing. So ignoring the velocity factor and multiple of a half wavelength, the best I got was about 1.4 to 1, typically was about 1.8 to 1, when the actual SWR at the feed point was 3 to 1. Next, I hooked up 100 feet of 400 max, and I had some other LMR 400. And with that connected, the SWR being at the beginning, again, 3 to 1, the SWR at the transceiver measured about 2.5 to 1. So the SWR was higher with the 400 max than it was with the RG8X. So why is it? Why would the SWR look higher with 400 max as compared to an old run of RG8X? Is the coax no good because the SWR is higher with the 400 max? Is there something defective about the 400 max? Actually, not at all. The difference is the RG8X, because it has fairly high losses, it also reduces the SWR, so it makes it look better than it is. And when I use the two bird watt meters and measure the input and the output, in other words, the input to the system and the output at the antenna side, with a 3 to 1 SWR, it was losing about 50 to 60% of the power in the cable. 400 max was around 20% or less. So if you're on a POTA and you run that coax out and the SWR looks good, it may not be very good, and you may be wasting watts. Same thing when you're at home. You may hook up a dipole, a vertical, no matter what it is, and the SWR needs to be read at the antenna, and if you can't get to the antenna, then a multiple of a half wavelength will help. So the shorter the run of coax to the feed point of the antenna, the better. If you can do a half wave, that's the best. So a high SWR with good coax is actually better than a low SWR with lousy coax, in this case RG8X versus 400 max. There's other versions of that, LMR 400 and other kinds of 400 coax that you can find that has relatively low loss at HF. So in my little switches box, the point was that I could pick different SWRs and do the readings. If the SWR was relatively low at the antenna, the losses were much lower. I set it up with the highest in the worst possible case. Doing that, I'm Jim W6LG. Thanks for watching. If you have any questions, post them below. If you have a comment, put that below. If you want to do a thumbs up or a thumbs down, please do that. If you haven't subscribed, I ask you to do that too. 73 from Northern California. See you the next time.